Welcome to the FLS1000 Video Tutorial 1, Introduction and Steady State Photoluminescence Measurements. The FLS1000 spectrometer is designed as a complete modular spectrometer. The excitation arm here shows a double Czerny-Turner monochromator, 2 grating turrets with the capability for 3 gratings each, and 2 lamps. Larger for the steady state is a xenon 450 watt lamp, and the smaller one is for phosphorescence measurements, a 60 watt microsecond lamp. The sample chamber shows the excitation path comprising of 2 irises, an excitation reference detector, a beam splitter, an excitation quartz doublet lens, cuvette sample holder, and the emission arm shows an emission quartz doublet lens and emission shutter. Also shown are 2 lasers. The left one is for TCSPC and the right one is for steady state or MCS. The emission arm here shows 3 detectors on a double Czerny-Turner monochromator, 2 grating turrets hosting 3 gratings each. We have an NIR PMT, a high-speed or lifetime PMT, and a visible PMT shown from left to right. Now let's look at our Floricle software. Floricle opens with the signal rate window centrally located on the monitor. The signal rate window offers the user a live observation on exactly what is happening in the spectrometer at any stage. The signal rate window itself offers the user a choice of source light path and detector light path, excitation monochromator wavelength and bandwidth, intensity filter setting. The live signal on up to 3 detectors can be shown in blue. In this case, it shows the signal on the excitation reference detector and the visible PMT 980. Adjusting the parameters and closing the sample chamber lid, we can now see the strong signal on both detectors. The signal goes red when the detector saturates. Bandwidths need to be selected to prevent this. The quick link to the Lambda menu offers the user a choice of steady-state measurement options on a standard system. Select Emission Scan and the Emission Scan dialog box opens up. The user can select ranges and scan parameters, as well as spectral and temporal correction options. Additional measurements can also be made live, in this case showing the excitation reference and uncorrected emission scans. The Apply button changes the parameter in memory. Start will begin the measurement. This data is recording the corrected emission spectra, uncorrected emission spectra, and the live signal on the excitation reference detector, which in this case represents the stability of the xenon bulb. Measurement parameters are shown. The software has a simple but powerful analysis functions. Perform an excitation scan from the Lambda menu or the Control X shortcut. Enter parameters and start the measurement. Excitation correction should always be used with the xenon lamp, since it records the live data from the excitation reference detector and applies this to the scan, removing temporal as well as spectral effects. We can combine the spectra together, normalize data, split spectra, and crop the ranges. Data can be saved as small FL or FS files or exported as usual to ASCII or CSV format. An excitation emission map can map the complete fluorescence of any sample, avoiding hazardous peaks to generate a 3D map or thermal diagram. Synchronous scans, mapping, and multiple maps can also be easily rendered. Emission correction can be performed live or at the end of a measurement. Measurements can be easily rerun by choosing the Rerun quick link. Batch measurements offer the user a very powerful but simple graphical scripting function, where a long sequence of measurements can be strung together to create a batch of measurements and commands which can be run, saved, and reloaded at any time. This batch wizard is based on previous measurements made either during this session or previously saved. It offers looping, delaying, exposure, and temperature control functions. This batch functionality will be expanded in future software versions. In normal operation, samples are exchanged by removing only the circular lid, or sometimes the front hatch. However, the entire sample chamber lid can be removed if necessary for inspection or cleaning. FLS1000 offers complete automation to the user. Changing the iris moves the intensity filter. Changing the light paths change the internal position of the mirrors. Swapping sample holders is easy and fast. Solid samples must be aligned using the knob and to ensure the beam is hitting the sample. The use of a long wavelength pass filter placed between the sample and the emission arm is sometimes needed in highly scattering powder samples. The transition wavelength should be a little longer than the excitation wavelength. Polarizer positioning and rotation is automated. Florical offers the user many data analysis and data manipulation options, such as normalization, integration, and smoothing. Scans can be easily combined and inserted. The FLS supports and offers many accessories, including our integrating spheres, cryostats, and plate readers. Thank you for watching our video tutorial, and we hope it was useful.